we are. Great. Well, so welcome everyone. I'm Mike Bevilacqua. I'm a nephrologist over in Surrey, and this is one of our webinar series where today we're going to be talking about getting to know your kidney lab work. So thank all of you for joining here. Before we get started, although we're meeting here virtually, it's always nice and I think proper for us to reflect on the various parts that we're coming from of the province, and actually some people even beyond BC, which is great. Myself here in Surrey, I come to you from the traditional territories of the Katsi, Semiahmoo, Kwantlen, and a few other Coast Salish peoples. And again, I think this would be a good time for everyone to reflect on the great part of the province or beyond that they're coming from as well. Today, we're going to be talking about getting to know your blood work. As some of you may know, this is one in a series of our webinars. If this is your first time, welcome, and we look forward to seeing more of you. If you've come to our previous ones, welcome back. For the whole series, this is all available on our BC Renal website. So there's a whole section for this that if you go to the BC Renal website, you'll find a section devoted to patient education webinars. And you'll find a few things there. You'll be able to find recordings of all the previous sessions, including today's. Today's is being recorded, and within a week or two, it'll be up there if you want to review it again. You'll get to see a calendar of all of the upcoming events. And there is also a little place where, oh, it's not showing on the screen, but a little button that says subscribe now. And if you hit that, you'll actually get a notification every time there's an upcoming session so that you can try to attend them live. So that's our little plug there of all of the sessions, and you can see the list on the right-hand side of the ones that are coming up over the next few months. A few housekeeping items before we go ahead and get started, though. So as you can see, we've muted you and turned off your audio, so you can see and hear us, but we can't see or hear you. That's very intentional, especially with recording, to keep privacy and confidentiality. But despite that, we do want you to get questions in. And so the way you can get questions in is if you type them in the Q&A box. So that's the one with the two little speech bubbles that says Q&A on it. If you type your questions in there, we'll collect them. And when there's a bit of a break in the presentation, we'll bring those questions forward. I always like to say that, if the question is very, very specific, about your own situation in this example, something about your own individual blood work result, we'll kind of shift it to be a general question and suggest the very specific ones you bring back to your own kidney team to go over your own individual results. But definitely all of those general questions, clarifications, things like that, we definitely want you to send that in. And so we'll monitor that and bring it forward to our presenters. The last item there that you see is that when you signed up, there was a little tick box that you said, if you said it was okay to notify your team that you attended, we'll do so. And that's not that we're keeping attendance or anything. It's mainly so that they know they can follow up with you if questions or anything come up afterwards. Okay, so that's how our session's going to run. That's the housekeeping items. But otherwise, what you're really here for is for the bulk of it. And today we're going to be talking all about your lab work. So you can see that we have these items. What does the tests mean? What are they important? And what can you do to influence them? So it's a really, really great session and always really highly rated. We're very, very lucky today that we have our repeat presenters. If you saw this last time in the presentations, they're here for a reprise, which is fantastic. We have Dr. Zalinardo and we have Jessica from the Vancouver General Kidney Care team who are going to take us all through this. And so with that, I will stop my screen and turn it over to you.
All right. Thanks so much, Dr. Bevilacqua. Okay, give me a moment here. All right. You can see my slides?
Yeah, it's perfect.
Super. Okay. Well, yes, thank you so much, Dr. Bevilacqua and the team at BC Renal for inviting Jessica and I back to talk to you all about getting to know your kidney blood work. It's a pleasure to be with you this afternoon. I just want to pause on behalf of Jessica and myself to acknowledge briefly that we are grateful to be working on the traditional and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh peoples. So the outline for today's talk, it'll take place in 6 parts. We will start with a brief overview of what the kidneys do and what happens in chronic kidney disease. We'll then move on to the meat of the matter, which is interpreting your blood work. And we'll talk about how you can tell how well your kidneys are working. We'll talk about what anemia is, what important minerals the kidneys handle, why the acid level in the blood is important and how we measure that. And finally, we'll talk about the albumin in your blood and what that level means. So without further ado, let's talk about the kidneys and what happens in chronic kidney disease. This figure here is an outline of really the most important functions of the kidneys. I think probably most people in the audience already have a familiarity with one of the kidney's main functions, which is to clean the blood of waste products. But the kidneys do many other things. They remove extra water from the body, and then they have a role in a number of other things, including helping to build red blood cells. They help to control your blood pressure, and they keep your body's chemicals in balance. And we're going to speak about a few of those a little bit later. So with that as a background, then, what is chronic kidney disease? Well, we define chronic kidney disease as damage to the kidneys that occurs over a period of months to years. And while CKD is a permanent state, often we can slow down the damage through changes in lifestyle and with medications. So what happens when the kidneys aren't working well? This can cause a few things. The first is a buildup of fluid and waste products in your body. It can increase your blood pressure. It can cause an imbalance of minerals such as potassium and phosphorus, which we'll talk about later. It can contribute to anemia, and it can lead to problems with your bones. Before I go on, I just want to direct you to a very useful information sheet that you can find on the BC Renal website. It's shown here and not necessarily meant for you to be able to read, but if you're unable to find it on the website, you can open up this presentation once it's on the website, and this pathway will get you to the handout, which includes many of the pearls that I'm going to be talking about today. So probably the most important thing that we get from the blood work is that it tells us, and urine tests, is it tells us how well your kidneys are working. To do that, we need a blood sample and we need a urine test. After we talk about how we determine how the kidneys are working, I will talk a little bit about what you can do to slow down kidney damage. So what blood tests help us to measure kidney function? The blood test that we get is called the creatinine. So creatinine is a molecule that is produced by our muscles that is freely filtered by the kidneys. And so creatinine itself is not a toxin, but because it's filtered by the kidneys and it's convenient to measure, it is our best, most practical measurement of kidney function. Once the lab gets your creatinine value from your blood test, it puts it into a special equation and comes up with what we call the eGFR, or glomerular filtration rate. And it's that filtration rate that is our most basic measure of kidney function. Ultimately, this is what is telling us how well your kidneys are cleaning your blood. So how do we interpret these values? What do the different levels of eGFR mean? Well, CKD is divided into 5 stages according to the eGFR measurement. So it's very important for us to know. A lower level of GFR means that you have less kidney function. So in the diagram here, what we have is the stages of kidney disease shown from 1 to 5, and the level of GFR that corresponds to that. So in the example here, I have someone with an eGFR, a filtration rate of 35 mils per minute, which we can place here in the diagram as a stage 3. So this person would have stage 3 kidney disease. If someone's eGFR was 17, they'd be in stage 4 kidney disease. But the blood doesn't tell us the whole story. We also need the urine to really interpret the degree of kidney damage someone has. And the reason for that is that damaged kidneys can leak protein in the urine. One of those proteins that comes from the blood that leaks into the urine is called albumin. And that is what we're checking in the urine when we are looking for evidence of kidney damage. And the test that we get is called the urine ACR test. So how does this work? So if we look here first on the left side of this panel, this is showing a healthy kidney. The white line across the circle, which says filter, imagine that is your kidney. And your kidneys are separating blood and all of the components of blood from urine. And so healthy kidneys eliminate almost no large blood components into the urine. So a healthy kidney eliminates almost no albumin, which is a large blood component, into the urine. And so the urine ACR test result is very low. It's less than 2. In a damaged kidney, you can see in the diagram here on the right, the filter has a hole in it. And when that happens, components from the blood that the kidneys should be keeping in the blood and out of urine can leak into the urine. And so damaged kidneys can leak a high amount of albumin into the urine, and that results in a urine ACR test that's abnormal. The urine ACR test will usually be 2 or generally much higher than that. And sometimes people will have a clue to the presence of albumin in the urine when their urine looks very frothy or foamy. It's the albumin protein that is leading to that frothing. So what treatments do we have that can help to slow down kidney damage? Well, there are many. The first thing is that it's important to control your blood pressure. High blood pressure will cause more damage to the kidneys. If you have diabetes, controlling your blood sugar is important. Quitting smoking is important. Trying to maintain a healthy weight and lifestyle is important. And finally, there are certain medications that can damage kidneys. For example, some common pain medications that are often used called non-steroidal anti-inflammatories or NSAIDs. Some common examples would be ibuprofen or naproxen. You really want to avoid especially long-term use of these medications because they can further your kidney damage. Beyond this, there are certain medications that can help to slow down kidney damage, and your nephrologist and your kidney clinic team will recommend if those medications might be right for you. Okay, I'm going to move on to talk about anemia. We'll talk about what anemia is and how we treat it. So, what's anemia? Why do we care? Well, to understand the relevance of anemia, we first need to start by talking about red blood cells and what they do. So the purpose of our red blood cells is to carry oxygen to our tissues to keep us alive. The oxygen is carried on a specific protein inside the red blood cell, which is called hemoglobin. And anemia occurs when you have a low number or deficiency of red blood cells or a low hemoglobin. They usually go together. The blood test that we use to diagnose anemia is found on a CBC, or a complete blood count. The hemoglobin, which is found on that CBC, will be less than about 115 to be anemia in a female and less than about 135 in a male. So the relevance of anemia is that it can cause symptoms such as fatigue and shortness of breath. That being said, mild anemia, so levels that are just below the normal range, tend not to cause symptoms in most people. So what causes anemia? Well, there's a whole myriad of things that can cause anemia. So the first thing is if you have anemia, you want to talk to your doctor to see what tests would be recommended to determine why you're anemic. The most common causes that we see are 2 in people with chronic kidney disease. The first is that iron can be low, and iron is one of the building blocks needed to make hemoglobin. And so if you have low iron, you can't make hemoglobin and your level will be low. The other thing that we can see in people with kidney disease is that their kidneys don't produce enough of the hormone called erythropoietin, or EPO. And when they don't produce enough of that hormone, then the bone marrow is not stimulated to make red blood cells. So when kidney function goes down, less EPO will be produced, less erythropoietin will be made, and that can lead to anemia. So getting back to the point about iron deficiency, because we always check for iron deficiency when someone is anemic, assessing iron assessing for iron deficiency turns out to require a few blood tests because there are many proteins that are involved in the absorption, transportation, and storage of iron in the body. The most common test that we use to assess iron for iron deficiency would be the iron saturation. And usually in people with kidney disease, we would consider normal or a good iron stores if your level is above 0.2. And the other test that we use is the ferritin. And in people with kidney disease, the ferritin can tend to run a little bit higher. And so we consider normal or adequate iron once the ferritin is above about 100. Now, these are just rough cutoffs to give you an idea of the numbers that we're looking for. So how do we treat anemia? What can we do about it? So if your iron is low, then first you might need more tests to determine why your iron's low in the first place. So it can be caused by bleeding, for example. So we'd want to make sure that you don't have any sources of blood loss going on. If your iron is low, you may need a supplement, and we can do that in a couple of ways. Most commonly, we do that with a tablet, but there are intravenous forms of iron available as well. If your iron is okay, but you still have anemia and your doctor doesn't think there are any other causes, then that could be that it's due to this erythropoietin deficiency because your kidneys aren't making enough. And in the case where your hemoglobin is less than about 95 to 100, your nephrologist might recommend some medication to treat anemia to boost up your hemoglobin levels, and that can be associated with a better quality of life. So it can give you a boost of energy, can make you feel better. The medications that we commonly use are two. One of them is erythropoietin, and the other one is darbepoetin. And these are given by an injection under the skin, usually every 1 week or every 2 weeks, and then we follow the levels of hemoglobin to assist in adjusting the medication dosage. How are we doing, Dr. Bevilacqua? Should I pause for some questions or carry on?
Yeah, perfect timing. There are a couple, and why don't we sneak them in? Maybe every 1 or 2 sections we'll pause. You guys are covering a lot of ground in this one. So the first one went actually back to the first section. One of the questions around urine tests was you talked about the albumin. Maybe just a quick note about what does it mean if there's things like hemoglobin or other blood cells that people might see on their tests coming back?
Sure. Okay, that's a great question. So when there are red blood cells in the urine, that could be a signal of kidney damage. Okay, so a leaky kidney filter can leak red blood cells in the urine. There are certain types of kidney diseases that can do that. But the other thing to know is that the red blood cells can come from outside the kidneys. They can come from the urinary tract, so the conduit of urine to the bladder and out to the toilet bowl.
Mhm.
So when someone has blood in the urine, then one of the important things to do, and often what we do first, depending on what the all the profile of the lab testing is make sure we're not missing something lower down below the kidneys that could be leading to blood in the urine. So that might involve a scan of your urinary tract, and may sometimes involve seeing a urologist who may take a look into the bladder with what we call a cystoscopy procedure, where they can actually see. It's like an endoscopy for your bladder. Other blood components that can be in the urine can be white blood cells. So we can see white blood cells in the urine also with various types of kidney disease, but oftentimes white blood cells in the urine signify other things. Like, for example, they can occur if the urine is a bit contaminated sometimes by the surrounding skin and it's not a midstream urine, or it can occur in people who have urinary tract infections. So the presence of these cells in the urine isn't normal. And so you always want to have a discussion with your doctor as to why they're there. But in some cases, they are not coming from the kidneys.
Beautiful. Perfect. And I love the phrase conduit to the toilet. I'm going to use that definitely. Okay, a couple other ones that came along. You had mentioned that people might sometimes get anemic with kidney disease. What about the other cell types? People are asking about platelets and all other things they might see on their tests. Is that
Okay,
typically impacted?
so typically those would not be impacted. So the hemoglobin is impacted because of the deficiency of the hormone that the kidneys produce, and that hormone is basically just stimulating red blood cells. The other cell lines are really not affected by kidney function per se. Now, you may have a kidney disease that is also linked with problems with other systems, in which case you may see things occurring together, but just low kidney function per se should not affect kidneys and shouldn't affect white blood cells.
Perfect. And then the next one, or maybe the last one I'll put in for this section is someone was mentioning, actually a very good question, that when they see their GFR test reported, it seems to change a lot, to fluctuate a lot. Is that kind of typical for this, or is it something worrisome?
Another great point. Yes. So there is some day-to-day variability of a person's GFR, even if their kidney function isn't truly changing. It can vary, for example, with how hydrated you are. So if you go to the lab fasting one time and not fasting another time, these things can lead to small changes in the GFR. The test itself in the lab has also some variability. So those two things combined can lead to some fluctuation in the GFR values over time. And your doctor will be looking for trends. So we usually don't get too concerned about noise along a baseline that's stable. Ultimately, can change by a few points. It's really what is happening over time is important in the interpretation. So we generally want to reassure people that small bouncing around of the GFR test is pretty normal.
Perfect. Okay, and then I'll just make a comment about some of the questions because there were some questions about medications, a lot around things like iron and stuff like that. I'll actually kind of defer that. This session, we're mainly talking about the tests themselves, but we do have a whole session about exactly that on the website. There's one recording about medications that we commonly use, and that's all right in there. So I'd point people to that one to go check it out. Okay, so yeah, with that, why don't we turn it back over into this next section here?
All right, thanks so much. So let's move on to minerals. So in the next segment, we're going to be talking about a few of the very important minerals that the kidneys handle, why they're important, and what you can do to treat abnormal levels of minerals in the blood. We're going to focus on 4 minerals today. The first is potassium. Then we'll talk about sodium, calcium, and phosphorus. Potassium. So why is the potassium level important? Why do we really care? So first, potassium is a mineral that's very plentiful in our bodies and found in many foods. And it has a very important function in stabilizing and helping your heart, your muscles, and nerves to function as they should. And the kidneys have an extremely important role in eliminating excess potassium that we take in our diet, for example, into the urine. So when kidney function goes down, the ability of the kidneys to eliminate potassium in the urine is reduced, and that can lead to a high potassium level in the blood. On your blood test, you'll see that a normal potassium is between 3.5 to 5. We tend not to be too concerned when the potassium is a little bit elevated, up to about 5.5 or so. But when the potassium gets very high, for example, higher than about 6, that can be dangerous for you because it can cause muscle weakness and it can affect the heart's ability to beat normally. So I'm going to hand it over here to Jessica, and she's going to talk to us more about potassium and ultimately also what we can do to treat a high potassium level.
Thank you, Dr. Zelenardo. So this is really an exciting time to talk about chronic kidney disease and potassium. There's been lots of research done over the last couple of years that has changed the way that we look at how we manage potassium and how we manage potassium levels. We know that our kidneys are responsible for maintaining the balance of potassium in our body, but we also know that not everyone needs to restrict potassium in their diet. There are many reasons why your potassium levels may be high. And this slide shows you some of the reasons why your potassium may be out of the normal range. So medications can raise or lower potassium, and Dr. Zelenardo will discuss medications later. And some of the other reasons, like over-the-counter natural health products, can also contain potassium that will affect your potassium levels. Health conditions can change how your body manages your potassium levels. And physical activity, if you're moving or not moving, can change how the potassium is treated in the body. Blood sugars also can impact the numbers. A high blood sugar reading can cause an increase in potassium. And when it comes to diet, too much protein can also make for too much potassium. And lastly is our bowel function. A lot of potassium is removed with the stool. So if there's any constipation, that potassium is staying in the body. So we like to review these factors, these other factors, before we start jumping on the diet. The diet is something that we used to go to first when someone had high potassium. We used to go straight to the food and limit and avoid and don't eat this and don't eat that. And I'm sure you may have been told by some of your friends or your family when you were diagnosed with chronic kidney disease that you need to avoid potatoes or bananas. But now we're looking at a new approach to how we treat potassium and potassium levels. So what to do if your potassium level is high? We'll go through this list in more detail in the next slides, but we used to think about milligrams of potassium, and if a food was really high in milligrams, we thought, well, that translates to high blood levels of potassium as well. But now we know that we need to look into more detail and not just the food and the milligrams of potassium, but how is that food prepared? Are you choosing fresh foods? Are you having a good fiber intake? Are there additives in the food? Are you eating protein foods in moderation? How is the food being cooked? Are you being active? And how are your blood sugars? So this slide shows us that choosing fresh foods most often is helpful in terms of potassium content. We can see here that a fresh orange has about 237 milligrams of potassium, where when you take that orange and you make it into orange juice, the potassium content increases to 496. So eating a whole fruit is a better choice than choosing juices or juicing or smoothies. Those types of drinks will concentrate the amount of potassium and will also make it easier for your body to absorb that potassium. Choosing fresh and whole vegetables is also our goal. We want to limit the way that it's processed. As you can see here, a fresh tomato, 215 milligrams of potassium, gets concentrated to 478 milligrams when it is processed into tomato sauce. We know that fresh fruits and vegetables are only 50% of the potassium is absorbed, but when it's processed into these soups and sauces and drinks, it increases to 70% of the potassium is absorbed. So fresh is always the best way to go. And when you're choosing fresh fruits and vegetables and whole grains and legumes, this is also increasing your fiber intake. And fiber intake is going to help keep your bowels regular. And regular bowel movements are going to help remove that potassium from your body. So what about potassium additives? Well, back in 2012, Health Canada encouraged the food industry to reduce salt and sodium in processed foods. So what the food industry did was it removed sodium and replaced it with potassium. And so now they've created a potassium additive and put that into our processed foods. And these potassium additives are highly absorbed, 90% absorbed. So eating processed foods is going to cause an increase in your potassium levels. There are over 40 different additives. This one here, this soup, has potassium chloride in it, and this soup has 350 milligrams of potassium for 1 cup. That's quite high, and considering that 90% of that is going to be absorbed, you will probably see that in your blood work. The other types of potassium additives that you might see on your ingredient list would be potassium phosphate, potassium lactate, potassium citrate. So it's important when you're grocery shopping to have a look at these labels and see what you can see where it comes to potassium. So this is an example of a label again. This one has potassium chloride as well. This Black Forest ham has, how much does that have? It has about 550 milligrams of potassium for 5 slices of ham. And as soon as it's processed and eaten, that's what's going to go into the bloodstream at 90%. Other processed meats like hot dogs, deli meats, vegetarian meat substitutes, electrolyte beverages like Gatorade, salt substitutes like no salt, powdered drink mixes, low sodium products that advertise that they're low in sodium are going to be using a potassium additive to help create that flavor. So this is just a review slide of limiting or avoiding these foods that have the added potassium. So checking the labels and looking for that keyword potassium in the name, potassium citrate, potassium chloride, potassium lactate, those ones that I had mentioned, can often be found in soups and deli meats, processed meats, pickles, salad dressings. So we need to just take a little bit more time at the grocery store when we're shopping and have a look at the labels. And then moving on to processed foods, that's also going to be higher in potassium with smoothies and juices and sauces and potato chips. And then lastly, if your potassium is high and it hasn't come from a potassium additive and it hasn't come from a highly processed food, then we will look at whole foods and those foods that may be high in potassium. But again, these are only 50% absorbed when they come from the whole food. So we also want you to enjoy your protein foods in moderation. Eating too much protein can raise your potassium level. Now, protein is something that we never really thought of as containing potassium. We always thought it was the fruits and the vegetables. But we do know that protein, animal sources of protein especially, can raise your potassium levels. And so what we want our kidney patients to do is to replace some of the meats, the animal proteins, with some plant-based proteins like lentils, legumes, tofus, and nut butters. And these foods do contain potassium, but they also contain a great source of fiber that helps your body eliminate it. How we prepare our food also affects our potassium. So cooking, this example of spinach shows that when you have raw spinach, you think of you're having a salad, maybe half a cup of raw spinach is okay. But then when you cook spinach and you get the same amount of half a cup of cooked spinach, you're concentrating that spinach portion. It would probably take 3 or 4 cups of raw spinach to make half a cup of cooked spinach. So we're just concentrating it by cooking it. Double boiling is one way to prepare food to help remove some of the potassium. So what we'd like to do with some of our root vegetables, like potatoes, is to peel and cut them or slice them, put them in a pot with lots of water, and bring to a boil. And when the water is nice and frothy and bubbling, discard that water, throw away that water with half of the potassium that's in it, and then fill it with fresh water and bring to a boil and finish the cooking. And that way you're removing about 50% of the potassium. The other way that we can remove potassium through cooking is through soaking. So soaking the vegetables overnight in a pot of water. or pre-boiling some, if you're making a soup, pre-boiling some of the ingredients and then adding them to the soup after discarding the water, and you throw away some of the potassium there as well. And just like the spinach, potassium is affected by portion sizes. And we do see this seasonally, like in the summertime when our garden is growing fresh tomatoes and strawberries and cherries. Oh my goodness. We will see people people's blood work come in with high levels, and I'll phone them and ask them, if there had been anything different in their diet. And they said, well, I've just been eating strawberries. I've just been eating some tomatoes. And then I find out that they have a garden and it's cups and cups of strawberries and tomatoes and cherries. And so even though they are good fruits and vegetables, the portion is different than how they normally eat, and that has affected their potassium levels in their blood work. So this is just a summary of tips for reducing the potassium in your diet. It's key to note that not everyone needs to limit the potassium in their diet. We'll go through all of those other reasons that your potassium may be high. And then if none of those reasons make sense, then we'll start to look at the food. Are you using fresh foods? Are you using processed foods? How are you preparing those foods? How are you cooking them? Are you double boiling? Are you draining and rinsing? Are you juicing? And how are your portion sizes?
All right, back to me. So what else can we do to treat a high potassium level? So as Jessica mentioned, there are some common medications that we use in people with kidney disease and high blood pressure and heart disease that reduce the ability of the kidneys to eliminate potassium in the urine. I've listed here a few common examples. One group of medications is the ACE inhibitors, medications like ramipril. Then we have angiotensin receptor blockers. One example would be candesartan. And then we have another group of medications that are called mineralocorticoid receptor antagonists, such as spironolactone and finerenone. And these are all very, very good medications that may very well be indicated for you. But sometimes they might need to be changed or stopped, at least temporarily, if your potassium level is too high. Once we've done everything else, if we feel like the potassium is still high and you need a bit of help, more help, to keep the potassium down towards the normal range, sometimes we use what are called potassium binder medications, which you take by mouth, and they will stick to the potassium in your bowels and cause that potassium to be eliminated in the stool rather than absorbed by your body. And if you need one of these medications, your nephrologist will recommend that for you. Transitioning over to sodium, or should we take
Yeah, I mean, we'll do a couple
questions
quick
first?
ones about
Sure.
potassium, just so it's relevant. I think they're pretty quick. Actually, it's a really good one. Because you mentioned, Jessica, that one of the biggest things was sticking with those whole foods. Now, when you said fresh foods are, for example, things that are frozen, or people even mentioned like, canned or tinned vegetables and things like that, where do you group that? Is that still fresh, or do you group that as, with the processed things?
Yeah, absolutely. So canned is also a good option. You can always rinse some of the juice away. If it's been sitting in the juices in the can, then there's going to be some potassium that is leached into those juices. Frozen fruits and vegetables is a great and economical way to go for your foods. Absolutely a good choice.
Perfect. That was the big one I wanted to sneak in. Okay, yeah, let's go for it for sodium.
Okay. Okay, so on to sodium. So why is sodium important? So first of all, sodium is a mineral that's very plentiful in our bodies, and again, found in many foods. And it's a very important mineral for regulating the body's fluid balance and also for our muscle and nerve function. When you look at your lab test, you will see that the normal sodium range is between 135 and 145. But interpreting the sodium level is not that simple. So when you see your sodium and the level is normal, that actually doesn't tell you that the amount of sodium in your diet or in your body is just right. As it turns out, Taking too much sodium in your diet can cause high blood pressure and swelling, and yet your blood sodium level measurement might be normal. So in the end, a low sodium level tends to tell us more, or an abnormal sodium level, I should say, tends to tell us more about how much fluid you're drinking rather than how much sodium you are taking in your diet or have in your body. So a low sodium level, less than 135, could be a signal that you're drinking too much fluid. And a high sodium level might be a signal that you're not drinking enough fluid, that you might be a little bit dehydrated. We can also commonly see abnormal sodium levels during an illness, for example, a diarrheal illness or a flu illness, where you're not eating and drinking normally. They're also affected by various medications that may need to be adjusted. For example, diuretics or water pills can sometimes have an effect that ultimately results in the sodium level being abnormal. I'm going to hand it over back to Jessica to talk about dietary sodium.
Okay, so what we've found is that most people have too much sodium in their diet. 1 teaspoon of salt is 2,300 milligrams, and that is what our recommendation for total daily intake for our kidney patients is 1 teaspoon of salt. But the salt really doesn't just come from the salt shaker. Only about 5% to 10% is from the salt shaker. It's coming from other sources, especially added to our processed and convenience type foods. So as we can see here, as our foods are processed, you can see them getting higher in sodium. Taking a cucumber and making it into a pickle really concentrates or really needs that sodium to preserve it. Same with a tomato to tomato soup and pork into bacon or ham. You're just really increasing that sodium. So I think by the end of this presentation, you're really gonna understand how much you need to look at the label. So just like potassium, we want you to stop and look at the label and see where your sodium is coming from. When you're looking at the label, you want to first look at the portion size and make sure that that's a realistic portion for you. For this one, it's 1 slice of bread has 100 milligrams of sodium. And from the side chart there, you can see that 100 milligrams falls into the go-ahead green category. So this product here shows you that it is a good choice. If you didn't want to look at the milligrams of sodium, another way to look at it is at the percentage. So this slice of bread shows you that you have 4% of your daily intake is coming from the sodium. And you can see in the scale on the right that 4% falls into the is a little category and also shows that it's a good product to choose. So the tips to reduce the sodium in your diet is to look at fresh foods first, limit the salty processed foods and their frozen dinners and mixed dishes such as pizza or canned soups and broths. Avoid foods that are marinated, canned, or smoked, cured, and some of your condiments as well. If you're out when eating, ask for the sauce on the side and ask for less sodium to be put on the food. And when you're grocery shopping, I don't know how true this is nowadays, but we always used to say to shop the perimeter. That's where you're gonna, around the outside of the grocery store, you're gonna find your fresh fruits and vegetables, you're gonna find your dairy products and your meats and your unprocessed foods. But also I do wanna make a note here that down the aisles, there's also some really great choices. We talked about canned fruits and vegetables. There's also canned legumes and lentils, packaged canned beans and vegetarian products that are also down the aisle. So it's just being aware of what you're grocery shopping for and not to be sidetracked into those unhealthy convenience and ready-made meals. So when you are trying to reduce the sodium in your diet, with some of the canned food, you can rinse them. When you're cooking your rice and your pasta and your cereals, don't add the salt. Use fresh herbs and spices and lemons and limes and ginger and garlic and all those yummy things to flavor your food instead of the salt. And if salt is something that's challenging for you, start slow. Any bit of progress is good progress. So if you're start by just cutting your salt intake in half and work your way towards healthy substitutes is a good start. And then when you're going out to eat, have a look and see if you can look at the menu before you go. Check online and see. A lot of times they have the breakdown of what's in the food, and you can avoid items in advance and know which ones are not a good choice. Get your sauces on the side and your dressings on the side. Some of our patients that go regularly for things like dim sum, we ask them to get a bowl of hot water on the side so they can rinse off some of the sauce that's on the dim sum products to help reduce the sodium. And choosing a restaurant where you order from a menu is also a good idea rather than going to somewhere like a food court where you have absolutely no control of the food choices.
All right, questions on sodium, Dr. Bevilacqua?
There's actually not really. You guys
Okay.
both must have done it perfectly, and we have well taught people in the audience, I guess, about sodium.
All right, well, let's move to calcium and phosphorus then. So the kidneys regulate minerals and hormones that are very important for our bone health and for our blood vessel health. And so we have 3 examples here. The first is calcium. Again, recurring theme here, calcium is found in our food. I've provided the normal range here, which is 2.1 to 2.6 on your blood work printout. And calcium in general tends to go down when kidney function is low. We also have phosphate, which is again found in food. The normal range is 0.8 to about 1.5. And opposite to calcium, phosphate tends to go up when kidney function goes down because the kidneys just aren't as good at eliminating it. The hormone that is involved here is called parathyroid hormone, normal value being less than about 7. And parathyroid hormone is important because it regulates calcium and phosphorus and also affects bones. And it tends to go up when kidney function is low. We're going to mostly focus on phosphorus here in terms of diet. And again, I'm going to hand it over to Jessica for that.
Okay, so phosphorus can be found naturally in foods. So things like our dairy products, our milks, our cheese, our yogurt are natural sources of phosphorus. And those naturally occurring phosphorus is only about 50% absorbed. So we don't worry too much about that is naturally occurring. But it's also used as an additive. And we call this hidden phosphorus. And so things that would have hidden phosphorus are things that are most likely to be processed and have it added as a preservative or to add color or flavor or stability to the food. Some common foods that have phosphates added as a preservative are convenience foods, our processed foods, and our fast foods. And these foods are also the ones that are going to be high in our potassium additives and our sodium as well. So the thing with phosphorus is it's not listed on the nutrition facts label, but it's listed under the ingredients. So you need to also look at the ingredient list. So here are some convenience foods that have a phosphorus additive to them. And just like potassium, you have to look for that key word of phos. So sodium phosphate, calcium phosphate, phosphoric acid, and dipotassium phosphate. These are all hidden sources of phosphorus that are absorbed at a high rate compared to the naturally occurring phosphorus. So these are examples of processed foods, deli meats, burgers, hot dogs that are going to have hidden forms of phosphorus in the form of sodium phosphate, monocalcium phosphate, and sodium phosphate. So as I said, look for that phos in the ingredient list. And if you see it, then to try and choose another product that is not using a phosphorus additive. Our dark colas, for example, Coca-Cola and Pepsi, use phosphoric acid in them and can increase your phosphorus levels. The clear colored pops like Sprite or 7-Up are better choices. They do not have phosphoric acid added to them. So tips to reduce the hidden amount of phosphorus in your diet is to look at the label, be able to read the label and look for the phosphorus additives. You need to look at the ingredient list and look for that phosphate, the phosphoric acid.
Okay, so moving on to what treatments we use for bone health. I think I should have put these 2 bullet points in reverse. First, I think we want people to be active. So keep up whatever physical activity you can do, maintain some exercise. The second part is that your nephrologist and your kidney care clinic team will advise you if you need medications to regulate these minerals and hormones for your bone health. So some common medications that we would use would be calcium. We would often give that with a meal to assist in binding the phosphorus that you take in your food to the calcium that you're taking with your meal so that it'll be eliminated in the stool and you won't absorb as much phosphorus, for example. Other things that we would use would be vitamin D, and there are various types of vitamin D that we use. And there are sometimes some other medicines that we use to help to regulate these minerals and ultimately help bone health.
Great. And actually, it leads in. So we have a couple questions in this section. It leads right into this. Someone's asking, you mentioned that calcium might be lower as kidney function goes down. If people are taking calcium, is it possible to take too much calcium?
Yes, is a short answer. So, yes, I mean, I would say that it would be unusual to get a high blood calcium because you're simply taking too much calcium, but we do see it. So this is something that you do want to ask your doctor and your dietitian about how much calcium should you be taking. So
Perfect.
more isn't necessarily better.
Yeah, there's a lot of things. Exactly. The right range. And there's a couple, maybe I'll just summarize it by there was a mention of how often should all of these things be checked? This is a good question, maybe a theme throughout. We'll just summarize it by saying it tends to be more often if your kidney function is lower and or if these levels have been out of range, less often if it's higher and if they've been stable, but definitely something to talk about with your own kidney team. Yeah, and just one person asked a question, just to clarify, maybe I'll just summarize it too. When we say parathyroid, it's not related to the thyroid hormone. It's just, the name just means para, means near the thyroid gland. It's just physically where it sits, but it's a totally different system. So I just wanted to take those couple little ones there. Great, yeah, why don't we jump in?
Okay, sounds great. Excellent questions. So moving on to the final couple segments here. So the first thing we'll talk about is the acidity of the blood. And as it turns out, the kidneys do play a very important role in balancing your acid-base balance. Sometimes we call that the pH, and you might have heard of that before. So why is the acid level in your blood important? Well, when the kidneys aren't working well, the acidity of the blood can increase because the kidneys just can't get rid of as much acid in the urine anymore. And when this gets more severe, it can lead to potentially more kidney damage and also can be hard on the bones and muscles. The blood test that we use to determine the blood acidity is called the bicarbonate, and normal is about 24. So it's when the bicarbonate starts to get low is what tells us when we've got a higher level of acidity in the blood. So what can we do about that? The first is, the recurring theme here is increase your intake of fresh fruits and vegetables. Those are ultimately a source of what we call base. So it kind of combats the acidity that may be building up in the body. And further to that, the choice of proteins can also be helpful. So try to sway the balance more towards plant-based proteins, which will be a lower acid load for your body than animal proteins, which would be a higher acid load for your body. Sometimes, if your acidity is high, which again we see in the blood as that bicarbonate level being low, you may actually need a supplement. And the supplement that we typically use is sodium bicarbonate. And it is just good old Arm & Hammer baking soda, basically, but we can give it in a tablet form so that it is more palatable. Moving on to talk about the blood albumin level, which is another blood test that you'll get, and protein. So first of all, what does the blood level of albumin mean? And second of all, we'll talk about protein and the advice for how much protein you should be eating. So what's albumin? Albumin is a protein that is made by the liver and it circulates in the blood. And albumin's role has multiple roles, but one of the roles is that it helps to keep fluid inside of the blood vessels, prevent it from leaking into the tissues. And it also transports many substances in the body. When you look at your blood test, you will see that as the albumin, and normal is about 35 or higher. So what does it mean if your albumin is low? There are many causes of low blood albumin. So as I said, it's made by the liver. So if you have liver disease, if someone has liver disease, maybe their liver's ability to make the albumin is low. So their albumin will go down. There are certain kidney diseases that are very commonly linked with a low blood albumin level. The syndrome that we talk about is the nephrotic syndrome. But other things can do it too. Things like inflammation in your body for whatever reason. For example, a severe illness like a bad flu or some other inflammatory condition can lower your albumin, as can malnutrition. So interpreting the blood albumin level is a little bit complicated. It doesn't necessarily mean that you're not eating enough protein just because your blood albumin level is low. That being said, we're going to focus here for a couple of minutes on protein intake. And again, I'm going to hand it over to Jessica.
So talking about how much protein is the right amount of protein in your diet. Does it matter? Is it important? Absolutely. There's such a thing as too little, and there's definitely such a thing as too much. And there are benefits to limiting the amount of protein and the type of protein in your diet. And what we can find is that by watching the amount of protein and type of protein, you can lower the risk of kidney failure, and you can also improve your cholesterol numbers. It is recommended that people with kidney disease avoid a high protein diet. And the reason for that is those waste products that the protein breakdown cause have to be removed by the kidney. And so if your kidney's not working at 100%, it has difficulty removing all of those waste products. So how much protein should you eat? I don't want you to get a scale and to weigh anything. I want you to have a look at your plate and see what the balance is. We want the focus to not be the meat and potatoes like some of us used to eat, but more looking at the plate and have half of your plate be your vegetables, a quarter of your plate be your grains, and a quarter, about the palm of your hand or about a size of a deck of cards, to be the meat or the protein. And we want to limit this quarter of your plate to twice per day. So some sources of protein that you know include things like your fish, your canned fish, eggs, chicken, beef, lamb. Now these pictures, it says 1 ounce, but the picture is a little bit more than that. We have a hard time finding the actual what 1 ounce looks like, but that's why we look at the palm of our hand to get a good portion size, and the palm is equal to 3 ounces. Vegetarian sources of protein, these are all examples of 1 ounce of protein from a vegetarian source. So a quarter cup of firm tofu is going to be 1 ounce of protein. Half a cup of cooked beans or lentils is 1 ounce of protein. So as you can see, you get more food almost with a vegetarian source of protein than you do with an animal source of protein. So 1 egg would be 1 ounce of animal protein, whereas half a cup of lentils is 1 ounce of protein. And then the foods that we'd like you to avoid in terms of protein are these processed hams and deli meats and bacons and pepperoni, hot dogs, fish sticks, Spam. These foods are not only not good sources of protein, but they're also going to be high in sodium. And as we talked about earlier, high in those preservatives, those potassium and phosphorus additives. So the ideal way that we're turning to nowadays is this Mediterranean type diet. And so this type of diet focuses on your fruits and your vegetables and your whole grains and your nuts and your seeds. And it asks for a limited intake of fish a couple of times per week, and then limiting again the red meats and sweets to rare or not often. And this is known to help improve your cholesterol numbers and lower your blood pressure. It's going to be high in fiber with your fresh fruits and vegetables, and your good fats from the fish. And so tips to help reduce the animal protein in your diet. The meatless more days, I like that, because we used to always say, well, just try and meatless Monday. Let's do a meatless Monday. But then people would be like, well, Monday came and went and I didn't get my meatless Monday in. And so now we're just like any day of the week works. So a meatless more day, let's include more days of the week that are meatless. Build your meals around the vegetables and not around the meat, just like that plate model. We want the half a plate to be vegetables, the quarter to be the meat. And just look at that serving size as the palm of your hand.
To end off, we wanted to mention a few useful resources. As I mentioned in the beginning, the summary information sheet regarding these lab tests can be found on the BC Renal website. And there's also many good pearls on the website about diet information. So I really strongly recommend you peruse the BC Renal website. And Jessica and the dietitians recommend this website for kidney-friendly recipes, and it includes a lot of vegetarian recipes. So would also strongly recommend this site. And Jessica and I are happy to take any more questions that you might have. And it's been a pleasure to meet with you, and thanks so much for your attention.
No, fantastic session, both of you. And yes, there definitely are some questions. There have been a few I've been typing away and answering them there. Just to reiterate, some that were pretty individual. So I do say, especially when it comes to, should I be using this medication in this situation, please take that to your kidney team to discuss, individual to you, because there are some considerations there. But yeah, we've got some general ones. Great. So I'll try to group them in order. So we just talked about the protein. This is a really good question, Jessica. It came up around things like these vegetarian meat substitutes like veggie burgers, I don't want to say trade names, but the kind of veggie based meats and things like that. Where does that fall in the
Yeah, it's kind of a mixed blessing that these products became really popular and encouraging plant-based foods. But unfortunately, they are full of the additives and the sodium that we don't want for our kidney patients. And so the best way to turn to vegetarian sources is to go to the lentils and the legumes and look for some recipes that would include those.
Perfect. Yeah, and not just the sodium, all kinds of ultra processed, ingredients in there. Yeah, perfect. Okay, this one comes up every time. I really love this question because we talked about, the acidosis and everything. What about using those, machines that carbonate your water for you? Any
Oh,
problems?
yes, that has come up many times.
Yeah, I love this question.
You know, I suspect that ultimately they don't make much difference, but you can use them. That's fine. I would say use Jessica's rule of thumb about carbonated beverages. If you can't read through it, then it's not a good choice because it probably has phosphorus in it.
Yeah,
But otherwise, I'm not too sure how much impact they truly have, but certainly no problem to drink them.
yeah,
Clear
exactly.
ones, clear ones.
That's right. Whenever I always get that question, my simple answer is if it was acidic enough to actually change your blood, you wouldn't be able to drink it.
Yeah.
It would hurt your mouth. So, but yeah, it's a really good question. And definitely a good substitute for those dark, pop and stuff like that. Uh,
Continue to use your soda stream.
yeah. So yeah, I wasn't going to say the trade name, but that's what came up. Yes. None of us have shares in SodaStream. Okay.
You know.
While we're on the subject of acidosis, this one was really good. Oh, someone asked, they were told there was some link between the acidosis and their potassium. Is that the case?
It is the case because there can be basically some exchange across your cells of potassium depending on what's happening with your blood acidity. There is a link. So sometimes actually treating the acidity problem can help to reduce the high potassium levels as well. And again, your team will recommend on that, but I think that's a very good point. Yeah.
Mhm. Okay, now it looks like we're going almost back up to the top of the presentation. Oh, actually, there was one that, yeah, kind of snuck in because we didn't mention, someone was asking about urea. Like they sometimes see that a lot on their blood test.
Okay, yes. Yeah, no, that's a good point too. I mean, it is it's another waste product essentially that the kidney handles. It's just that there are many things that affect urea besides kidney function itself. So it's the interpretation is slightly more complex, and we can't link it directly to a level of kidney function, other than to say if as your kidney function becomes lower, and really as it's quite low, the urea is likely to be high. And it helps us in certain other ways. For example, in people who have somewhat better kidney function, it can sometimes give us a clue that someone might be dehydrated because the urea can go up disproportionately when someone is very dehydrated. But as a real kind of simple measure of kidney function, unfortunately, it doesn't do that. So it's better to look at your creatinine and your GFR if you want a real assessment of your function.
Perfect. Okay, and then yeah, back to GFR. So there's a couple really good questions here. Someone asked us maybe to comment on if the GFR levels are differently interpreted or calculated for people of different ethnic and racial backgrounds.
So historically, we have done that. The equation that we've used to convert, let's say, that creatinine value to the filtration rate. Basically, what that equation does is it takes into account basically things that sort of are linked to kidney function that are not creatinine. So age is one, and male or female is another one. And the equation was derived with an adjuster for race, and the race adjuster in it was for Black race. but we don't adjust the equation here in BC. We actually do not adjust for race. And in fact, there is a newer equation that has been developed in the last few years that is replacing the kind of previous version where race as a variable in the equation is getting eliminated by adjusting other things in the calculation.
Perfect. Yeah, and it's always an evolving field. That's why you might
Yes.
see this kind of
Yes.
change, as years
Yeah.
go on.
And, just maybe to explain further that the reason that race was in there was really because it probably is a surrogate of muscle mass potentially. So these are all these things like male versus female and age, basically because they're important things that are linked with muscle mass, and creatinine production is linked with muscle mass. That's why those adjusters are in that equation.
Perfect. Okay, while we're on the topic of GFR, because there's a couple. Oh, right. So earlier we were talking about, there's a question about variability of that GFR. And someone asked, when we say, oh, a little bit of variability is okay, I don't know if you want to give a rule of thumb as to what you suggest to people that is kind of within that usual range that you're okay with.
Partly it depends on what your level of kidney function is. Okay, so if your kidney function is still very good, like let's say your GFR is, I don't know, 80, 90, then sometimes what happens is you will have a small change in your creatinine level that then when you plug it into the equation leads to something that seems very dramatic in the GFR. Whereas when you have lower levels of kidney function, the GFR calculation is a little bit less sensitive in a way, I guess, that's probably the best way of describing it, to these kind of changes in your creatinine values. So I think you are your own best predictor of what the acceptable change is. So once we know a person and we see what their values have been, that's really how we get to know. We know that Mr. Smith, oh yeah, I know his GFR always fluctuates by 4 or 5 points. Then for Mr. Smith, that's kind of what we accept. So I think it's best to establish a pattern within someone than to give you a value. So I'm not trying to be vague. I just don't want to lead you astray either.
That's perfect. I say the same thing. It's the trend. We never jump too much at one number. We like to see, are you within your usual trend?
Yeah. And there are other things going on to make us think that change is significant. Like, are you unwell? Did you start new medications? Do we actually have a reason to think that your kidney function might be getting worse? And if we don't, then we're often, if it's not a clear trend, likely to interpret it as a fluctuation and then ultimately repeat the lab test, right? If we're not sure.
Perfect. Okay, while we're on the subject of GFR, this is a good one. We're kind of getting a little bit beyond, but it comes up commonly. Is it normal for someone's GFR to go down as they get older?
Well, whether it's normal is a matter of some controversy. Okay.
We can't agree on this in nephrology. Yeah.
But I would say that it is common for GFR to decline by about 1 point per year. We kind of consider that not necessarily indicative of some pathology that we need to intervene on if it's not accompanied by other evidence of kidney problems. So for example, more protein in the urine, blood in the urine. So we kind of look at everything as a package. But often in older age, we will not necessarily see as unexpected or atypical a slight drop in kidney function by about 1 point per year or so.
That was a perfect answer.
Thanks.
And maybe the person who asked this was aware why we're saying it's not normal. It's because you will meet 90-year-olds with perfectly intact kidney function. But I love that answer of common, and we're looking, what we really care about, is there a problem associated with it? Perfect answer. Okay. I'm just scrolling through here if there's any others. And this is actually most of the big ones. Maybe while just if anyone wants to get any last minute questions in, I'll put up our slides again just while we finish off there to show where all of this could be found. Because one of the questions that kept coming up is, where can I get these? So again, if you go to to the BC, oops, I hit the button. If you go to the BC Renal website and follow this series of events, so learning events and patient education webinar, within usually about a couple weeks, this exact presentation will be uploaded there. So if there's anything that you want to watch for a second time, that's where you'll be able to get that. Hey, we also encourage people to hit that subscribe now button so you'll know about our next coming sessions. You'll see here the dates. We have one coming up about kidney transplants, and we have one about treatments for kidney failure. So if you're interested, please check those ones out. And then the only other item I want to leave people with is that once the session's over, you'll get an email about an evaluation form. We do love that feedback, so please do get that to us to help us improve these sessions as we go forward. Otherwise, I'm just scrolling through. I think we've got most of the big ones. A lot of the other questions are about very specific levels. Again, I would kind of suggest that you bring those back to your own team to talk about that, since they are quite individual. So otherwise, I do want to thank everybody here. So I want to thank all of you for attending here and giving us your Friday afternoon. There's around 50 people on the whole time, so it's fantastic participation. So thank you all for coming out here. I want to thank our team from VGH here. So Dr. Zalinardo and Jessica, thank you for once again just a fantastic session. A lot of great positive feedback is coming here in the chat too. So thank you.
Well, thanks so much. I had fun, and we always enjoy doing this session. So it's great to meet with you.
We're going to ask you again then. So yeah, that's great. This is definitely an ongoing, a recurring one. And then, yeah, I also just want to thank, behind the scenes, we have Janet and Alexis and our whole team at BC Renal who makes this webinar magic happen and puts this all together. So thanks for doing that. And otherwise, yeah, thanks again for attending. And we hope to see you at our next session in March.
All right. Bye-bye, everyone.
Okay,
Hey, everyone.
bye.